Hi guys, today we are going to look at this problem, the skyline problem. This is a very tricky problem and I think can be well explained using the first example that is given in the problem. So first let's look at the problem. It's given that there are buildings and each building is having a left pointer where it starts, that's the left corner, and the right pointer, that's the right corner. The not pointer but index. And this is the height. So this is 10. And again, we encounter another building that is 3, 7. From look at it here. So from the second building is from 3 to 7. Sorry, 3 to 15. 3, 15 will be the left corner and 7, 15 will be the right corner. Again, the third building is 5, 12. So 5, 12 will be the left corner and 12, 12 will be the right corner. So this is how it is. So first we are told that we have to find the skyline, that is the overall border, which will eventually be seen if the hidden parts are removed, right? So this is the hidden part, the red, the below part of the red building is the hidden part. And again, the little bit of the green is also a hidden part. That's why this will eventually form a corner, and that will be the points that define those corners will be the answer. So initially, if we try to look at this, look at the input and the output as well, right? 210 will be the output, and then we encounter a collision between the two buildings, and that's why we take the building that is the maximum height. And then eventually we go down and find the next maximum height for the building that currently we have, which will be green. Then this goes on. So before we do anything, we have to separate the 2 points and with its height. So we can just do it like 2, 10, 9, 10. That will be 2 points. Then 3, 7, 7, sorry, 3, 15 and 7, 15. That will be next point. Then 5, 12, 12, 12 will be another point, and then so on and so forth. On top of that, this also has some line sweep algorithm hidden in it, uh, because we need to keep track of which is the building that we are starting. So I mean the left corner and the right corner of a building needs to be distinguished, because that's how we'll realize that a rectangle or the building is over or it's starting, right? So we have to do two separate actions for these. That's why we have to distinguish it. So that can be done using, a negative sign, because that's what we do in line sweep algorithm, right? So 2, 10, that will be 1 point, and 9 minus 10 will be another point. That's how we'll define if it's a, active rectangle or a rectangle that is just over. So we need to remove that from our track. So let's do it step by step. We'll just remove the pointers, and that can be stored in a vector of vector, which we can call corners. Here we don't need to define the size right now. I equal to 0, less than buildings, or probably we don't need to enumerate buildings, corners, but push back. Here we'll add a vector with b of 0 and b of 2. So notice this is the positive sign. So later whenever we encounter a positive second index, in that case, this is a rectangle which is just starting. This building has just started. And again, I can just copy this down. Here it will be negative, and this will be first index. This is the right corner, which indicates this negative sign indicates that this building is over. We need to remove all of its track if we are tracking anything. That will later, as we go through the problem, we'll understand. So this is it. Now we have something like, let's just also print it. Auto C corners. Uh, this will be first index. This will be the second index. Let's see this way. So here, so now that we have printed, here we see 210 and 9 minus 10, right? So this, uh, and then we see another building 315, right? So don't you think that we should have sorted this based on the x index, uh, right? Because as we go along the x plane, we encounter different points of different buildings, and that different buildings are nothing but the uh, sorted list of the first index, right? 2, 3, 5. That's what we encounter, right, as we go through this x plane. So we definitely want something like this, that will be corner dot begin and corners dot end. So this is what we need. Now if we try to print it, we'll get the correct order of the buildings that we encounter as we go through the explain. Alright. So now that we have updated the input in a well defined way, and we know which point is the start of the building, which point is the end of the building, and we have sorted it such that we encounter the correct buildings as we go through the x direction, right? So let's see how we are going to process this input. So we are right here, and we see that we are at zero height. So initially we can have a bucket. We just increase the index or the weight. This is the bucket. I don't know which data structure right now, but it's a bucket. We are keeping track of the heights here. Initially the value is zero. All right, and I also have a variable which will have which will call the current height, and that will be initialized with zero value. So as we and we'll have the answer as well. So, so this is the answer, right? So as we go forward in the x direction, we encounter a, a point which we know because it's positive. We know that this is a start of a rectangle. So we have to keep track its height in the bucket. So remove it, uh, cross it since this is going to be processed now, and we'll increase the elements in the bucket, and with the value of whatever has been encountered, and the current height will also be increased to 10. And we know that the maximum height is the one that we are going to see as a corner in the skyline. This value will be added to the answer. Alright, so we are right here. Let me just increase the weight. We are right here. And we move forward and we encounter another point. And that is this 315. 315, we see that the height is again needs to be updated to 15 and the bucket needs to be added with the value 15. Alright, so the next point that we are going to, sorry, I'll also update the answer as well. Every time we do a addition of a rectangle, we have to update the height, update the answer. There will be scenarios where we don't need to update the answer. Why? We'll see that. In the next point itself, we'll see that. This will be 315. Alright. So now we encounter 512. We move forward and we encounter the left corner of the green building, that is 512. This is the one, and we see that 15 12 is not equal to 15. If it was equal to 15, then uh, I wouldn't have done anything. But if it was greater than 15, then I would definitely update the current height. But since it's less, I'm not going to update the current height, but I'll update the bucket because this definitely needs to be updated. Because as soon as we encounter a minus 15, we are going to remove this from the bucket. And then the current height, the maximum height will be 12. This will be this will play some role later. That's why we have added this in the bucket. And as we speak, we encountered minus 15. So we are going to remove it from the bucket and we are going to see the next maximum height. So we are getting a intuition of what data structure we are going to use. On top of that, some more hints is we can have multiple 15s or multiple 10s at this point, right? So we have to have separate instances or separate values of the frequency here as well. So we can keep track of the frequency as well. So we are, you know, understanding that this can be a priority queue or this can be a multi-set or this can also be a ordered map, right? We are going to use ordered map here for this data structure, but either of the three can be used. So 15, now this is going down to 12, right? And 15 is removed from the bucket and 7 is the point where this happened, is 7 and the current height, that is 12, will be added here. Similarly, now we move forward, we encounter a point that is this. 9 minus 10. Yeah, so this has been encountered, right? This is what we got here. 712 is this point. Yeah, this is so this fourth, fifth. So this is the point where we encounter where we are as of now, right? 715 is this point. Sorry, 712 is this point. So this is the collision of two different buildings. So we have cracked that. Yeah, we are able to solve that. There's another issue that is when we have similar heights of 2 points, and that can be easily solved using this. I mean, I will get to that. So as we move forward, we encounter the right point of a building, that is the green one. That is 9 comma minus 10. So since we have encountered a negative, so we know that a rectangle is going out of the bucket. So this minus 10 will be removed and we are going to see that 10 is less than 12. So we are not going to update it, right? We're not going to update the answer. Now we see that we encounter another right pointer of the green. Sorry, this was the left the right pointer of the blue building, the one that we encountered, 9 comma minus 10, and now we encounter the right pointer of the right index of the green building. We'll just remove this from the bucket. Uh, we remove this from the bucket. Since we have removed this, what's the maximum height in the bucket now? 0. What's the point that we have encountered this at? 12. So 12 comma 0 will be the answer. So now we see, and this process can be again and again repeated for the different buildings that we encounter. So the next thing that I wanted to discuss was a corner case, which can be explained using this example. Here we have two buildings, right? And both of the buildings are ending at the same point. So the x coordinate of both the buildings are 6. Here, since we are sorting 4, 5, 6, we will get 4, 5 in the correct order, but for 6, we might get this point before or this point before. That depends on the original structure of whatever it was given. If we are not sorting it, if you're sorting it, then it's good enough because we have to sort it. And let's see why we have to sort it. Because if we get this is the right pointers, right indexes, so this will be minus 8 and minus 10. If I get minus 10 before minus 8, then that will be a problem. So at this point, we are at this state 0, 8, 10 are in the buckets, and the current height is 10, and we get minus 10. So we have to remove it from the bucket, right? We remove it from the bucket. The next height that we encounter is 8. We are going to update it to 8. So currently, what was my answer right now? 4, 10. This was already there. The next point will be 6, comma 8. That's wrong. Let's see what we get later. What will be the complete answer for this wrong approach? We'll remove it now that we have encountered minus 8. The next thing that we encounter is minus 8. We'll remove it. The next height is 0. There got 0, 6. So next answer will be 6, comma 0. What should be the ideal answer? This should be the ideal answer without this. This should be the ideal answer, right? 4, comma 10, 6, comma 0. Now, if we do it other way, if we encounter minus 8 before minus 10, we remove it 8, and we don't update the current height, we still have 10, and then we get minus 10. We remove it from the bucket, we have 0, and that we add it. So we don't add it here. This extra thing would come, and that will be the right answer. So if we have same x, then we have to update uh, the height based on ascending order of the absolute value. But since they are negative, so we have to do it descending order. So let's start. Let's remove the print statement here. Let's have a capture function, a comparator, auto, LHS, auto RHS. Here we are going to see it, since LHS and RHS are vectors with two indexes. So if LHS of 0 is equal to and RHS of 0, in that case return LHS of 1 greater than, since this is negative, so we are going descending order, RHS of 1. Alright, and we return LHS of 0 less than RHS of 0. This is ascending order of the first indexes. Now comes the bucket part. So what should be the bucket? As we have seen, we are going to keep track of the frequencies also. We can have multiple tens, right, at a point. And then we encounter a minus 10, we have to decrease that frequency and see if it's 0 or not. If it's 0, then we remove it, we erase it. We can have an ordered map. This will help us in two ways. It will keep the things sorted because we need the next maximum height, and we are going to keep track of the frequencies as well. So that's, otherwise we can go for multi-set as well, or we can go for priority queue as well. Let's see, we are going to create a map that will be ordered, and the initial current height will be 0, and the map will be updated with the initial value, which is 0. So I'm going to traverse to the x coordinates, that will be the corners, right? If c of 0 or c of 1, if it's negative, then what we are going to do? If it's negative, sorry, if it's positive, then what we are going to do? We're going to add it straight away because this is a rectangle that's starting. So we have to add it. C of map, C of 1 plus plus. Else, if this was negative, then we are going to decrease it. C of 1 minus 1. But if map C of 1 is equal to 0. In that case, you can just leave it in the place 0. Right. So now we do the bucket part. We have done the bucket part. Now we see what's the current maximum height, and we update the current edge with that height. So if uh, current height is not equal to the maximum height which we can get from the map like this argument, and that will be first and second. So first will be what you have to compare. Second is the frequency. If it's not equal, in that case, I will add it to the answer. I'll have answer as well, which will be a vector of vector, and we'll add push back. This will be C of 0, because that's the point we are encountering this, and current height. Current height will be updated to what? This will, so this we have to update it before we add it to the answer. So current height is equal to this maximum possible height in the map. So the answer will be let's see if it works, and it doesn't. Let's see what's the problem here. C of 1 is greater than 0. We add it, otherwise we subtract. We have to subtract since we are having minus value here, right? C of 1 is negative. We need to remove negative values. That will be positive, right? So in turn, we are going to always have positive values in the map, irrespective of whatever we encounter, positive or negative in the corner. Uh, I, that will be negative as well. It will be negative as well. That's it. Let's see if it works now. It does. Let's submit it, and it does work. The time complexity will be, since you're using map, it will be n log n. So log n will be the operation for the map, for ordered map, and we are doing it for every corner. This will be n log n operation, at least as far as I think, and the space complexity will be O of n. That's it. Thank you guys.